So in this session we shall learn about the dimensions and units of work, and for this we will require the formulas we have learned earlier about definition of work. So let's start. Now first of all, let's recollect the formula that will guide us in finding dimensions and units of work. That formula was numbered 1, and this is the work done by a force is given by magnitude of force into magnitude of displacement into cosine of the angle between the force and displacement vectors. So F and S vectors, and angle between them is theta. This was the definition of work. So you see that dimension formula of work that is given by this symbol in square bracket, that can be written to be the dimensional formula of F, dimension of F into dimension of S into dimensions of cos theta. Since force is mass into acceleration, so mass dimension is m, acceleration is length by time square, so that part is coming out to be L into t to the power minus 2. This is the dimensional formula of force. Displacement is the length, so its dimension is L, and then cos theta is the ratio of two lengths. It's based by hypotenuse in a triangle, so that is just a dimensionless number. Either you write nothing, or you can write formally m to the power 0, L to the power 0, t to the power 0. The dimensionless number, you might even omit it, write nothing, and this is coming out to be the dimension of work is coming out to be m L square t to the power minus 2. This is what we have got. So let's write it separately. The dimensional formula of work is m L square t to the power minus 2. This is our first important result, and that we number 1 here. Now this dimensional formula will guide us to decide the units of work. Let's consider the SI unit of work in absolute units here. Absolute unit of work in SI, that is international system. So to do that, we shall recall that the unit of work, now the unit of mass, you can see here, I'm looking here only and finding out. We just need to recollect the units of different quantities or different physical quantities inside the square bracket. Dimension of mass is kg in SI. Dimension of length is meter, so I write meter square, and don't forget to give a hyphen in between. This is a compound unit. And then again hyphenation. Time unit is second, that's seconds to the power minus 2. Now this is same thing as writing kg meter square per second square. This quantity you can verify yourself is same thing as Newton meter, where Newton is the unit of force, and this is the quantity that is known as Joule. That is the abbreviation, the symbol. The actual word is named after a scientist, and this is Joule, named after an Englishman. This is the complete name of the unit in SI, absolute unit, and the abbreviation is of course Joule. But let's go there more systematically and define different types of units of work now. The units of work are of actually two types. Now one type is called absolute unit. Absolute unit, and the other type is called gravitational unit. The second type involves the concept of gravity. Gravitational unit. Okay, and each of them can be expressed in either SI, the International Modern System, or in the earlier CGS. Okay, so SI or in CGS. And what are their names? They have got names actually, so let me write them as well here. The SI absolute unit of work is called Joule. The complete name and the symbol is capital J because it's named after a scientist. The CGS absolute unit, that is absolute unit of work in CGS system, is called arg. It is arg, and that is the same thing in symbolic form as well. There is no smaller abbreviation. The SI gravitational unit of work is called kilogram meter. This is called kilogram. I am writing the complete name, kilogram meter. You must give a hyphenation between the two parts of a compound unit, and obviously in symbolic form that is kg-m. And similarly, the CGS gravitational unit of work is gram centimeter. I'm just writing the symbolic form, and this is called gram centimeter. So we shall define each of them one by one. Now let us see what is the meaning of 1 joule. 1 joule of work, this is absolute unit, and SI in SI, International System. 1 joule of work is done when a force of 1 Newton acts on a particle to move it through a distance of 1 meter in its own direction. So you can just visualize the definition by drawing a diagram here. Suppose this is a particle, it's a block of size small enough so that we can treat it as a particle. And here is the force acting. This force is 1 Newton. Displacement of the particle is in the direction of the force. That's important. This is the red arrow, that is displacement. So you see what they are telling is this in the definition. This force is in this direction and displacement is in the same direction. They are parallel. The magnitude of force is 1 Newton. The magnitude of displacement is 1 meter. And very importantly, the angle theta between the F and S, as you can see, they are parallel vectors. This angle is 0 degree, so cos theta is coming out to be 1. So you can look above and can see the corresponding work should be written to be 1 Newton. I'm talking about this equation. Let me number it 1 as usual. This was equation number 1. So looking at equation number 1, we can see 1 Newton for the value of F.
Hello students, you got a glimpse of our video lessons through this small lecture. We have hundreds of lectures like this one covering various topics of advanced school level and intermediate physics in our website. They are exhaustive and often accompanied by elaborate diagrams to make concepts even clearer. They are taught with passion and sometimes with a bit of fun. So, at the end of the lesson, you have a commanding grip on the subject and you are ready for the board and competitive exams. Subscribe at physicsacademyonline.com to access video lectures of highest standard on various topics of physics.